All right, so we're just going to do a couple of quick problems here. An example of balancing a redox reaction in acidic solution, and then we'll do one in basic conditions. So as we take a quick look here, we've got our redox reaction. I'm just going to work through the steps that correspond to what we just discussed in your notes. The first step is to identify the half reactions. And so in order to figure out what the half reactions are, we need to know what is being oxidized, what is being reduced. So as we take a quick look at our reaction here, the very first thing you want to do is then write out the oxidation states for each of the elements in this reaction. As we take a quick look, we know that oxygen is mostly always -2, which means that chromium in this example must be +6. Again, oxygen is going to be -2, which means nitrogen is going to be +2 here. The chromium 3 ion is going to be easy enough, +3. Oxygen again -2, which means that the nitrogen in the nitrate ion is going to have a +5 oxidation state. So as you take a quick look at those oxidation numbers, we can tell that the chromium, it has gained electrons to go from a +6 to a +3 oxidation state. And then as we take a look at nitrogen, it has gone from a +2 to a +5 oxidation state, so it must have lost electrons. And so as we take a look at that reaction, we can then write out our two half reactions. I'm going to do the oxidation half reaction over here, and the reduction half reaction over here. And as we take a again, quick look at the oxidation reaction, it's going to be the NO, nitrogen monoxide, forming that nitrate ion. And that's the oxidation half reaction. And then our reduction half reaction is going to be the dichromate ion, or the Cr2O7, 2-, forming that chromium 3+ ion in solution. So step one is just to identify the two half reactions, which we've done there, the oxidation and reduction half reaction. Step two is to balance your atoms that are not hydrogen and oxygen. In this case, the non-hydrogen and oxygen atoms are already balanced in our oxidation half reaction. In the reduction half reaction, in order to balance our chromium, all we need to do is add a 2 in front of the chromium 3 ion. That'll balance our non-oxygen hydrogen atoms. Step 3 then becomes, well, let's balance those oxygen and hydrogen. As you take a quick peek at the oxidation half reaction, in order to balance out the oxygen, we're going to add water. So we're going to do H2O, and we're going to need 2 of them. So we have a combined total of 3 oxygen on the left-hand side to match the total of 3 oxygen we have on the right-hand side. And that balances the oxygen. To balance the hydrogen, we're going to add the hydrogen ions. And again, we can do this because we're in an acidic solution, and so we've got all these free hydrogen ions just sort of floating around. And we're going to add, 4 of those hydrogen ions to match the 4 hydrogen ions that are on the left-hand side of the reaction. So now we've balanced all of the atoms for our oxidation half reaction. We want to do the same thing for our reduction half reaction. So as we take a look at our reduction half reaction, we're going to add water, but this time we're going to add it to the right-hand side of the reaction. And we're going to add 7 waters so that we get 7 oxygen to match the 7 oxygen on the left-hand side. To balance out the hydrogen, we've got 14 on the right-hand side, so we need to add 14. We're going to add, to balance out the 14 hydrogen on the right-hand side, we're just going to add 14 hydrogen ions to the left-hand side. That will balance the hydrogen and the oxygen in our reduction half reaction. Step 4, quattro. Okay, and as we look at our oxidation half reaction and trying to balance it for charge, there's no charge on the left-hand side of the reaction, but on the right-hand side, we've got a -1 from the nitrate ion and 4 positive ones, which means we've got a total of +3 charge on the right-hand side. So in order to balance out our charge for the oxidation half reaction, we're going to have to add 3 electrons to the right-hand side. And notice then now the total charge on the right-hand side is going to match the total charge on the left-hand side, which is 0. And that makes sense because in our oxidation reaction, we're losing electrons. So as these two things react, we're going to be giving up 3 electrons. As we look at the reduction half reaction, on the left-hand side, we got 14 positives coming from the 14 hydrogen ions. We've got -2 from the dichromate ion. On the right-hand side, we've got 2 of these chromium-3 ions for a charge of +6. Again, we need the charges to equal one another on either side of the reaction. So we've got +6 over here on the right-hand side. We've got +12 over here on the left-hand side. If we add 6 negative electrons, that'll take us down to +6 on the left-hand side to match the charge that's on the right-hand side. So step 4 is to make sure that you balance your charge. And once you've done that, as we've done here, we are 2 steps away from completion. Step 5. You may have to, and we will in this case, multiply one or both of our half reactions to ensure that the charge lost is equal to the charge gained. If you look at our oxidation half reaction, we have lost 3 electrons, but in the reduction half reaction, we've gained 6. In order to get the number of electrons lost to match the number of electrons gained, we'll just have to multiply this by a factor of 2. And again, you're going to have to multiply everything by a factor of 2, because if we're trying to get a total of 6 electrons lost, that needs to distribute throughout the entire reaction. So now we're going to have 6 electrons lost, 6 electrons gained. Our final step number 6 is just to recombine our half reactions into one full redox reaction. So I'm going to rewrite my oxidation half reaction distributed with that factor of 2. So we're going to have 2NO plus 4 H2O, forming 2NO3 minus plus 8 hydrogen ions plus 6 electrons lost. Our reduction half reaction, we're going to have 6 electrons gained plus 14 hydrogen ions plus our dichromate ion. And on the right-hand side, we'll have 2 chromium-3 ions and 7 waters. And then to combine these, you can cancel out anything that appears on both the left and right-hand sides of the equation. So we're not going to describe or actually write in the 6 electrons, although we do need to recognize that 6 electrons or 6 moles of electrons have been lost and gained here. You can also cancel out waters. Those 4 waters on the left-hand side will all cancel out and be left with 3 on the right. You do the same thing with the hydrogen ions. We'll be left with 6 on the reactant side. And so when you finish up here, our complete balanced redox reaction using the half reaction method is going to be 2NO plus 6 hydrogen ions plus our dichromate ion. And on the right hand side, we're going to have 2 of those nitrate ions plus 2 of those chromium ions plus 3 of those waters. And that represents your balanced redox reaction in acidic solution. Boom.